algebraic notation. This is how we represent a short form of representing large numbers in STEM, science, technology, engineering, and mathematics. It's very important that you do this so that you will not be writing large numbers. So, we bring in the index notation, but this time around, the index part will be that of the powers of 10. Let's look at the index part first. If we have 100, this will be equal to 10 times 10, which is 10 raised to the power 2. You get that? If we have 1 million, that will be 10 raised to the power 6. You understand this? Now, let's look at numbers less than 1 for 1 over 100. This will be 1 over 10 times 1 over 10, which is 10 raised to the power minus 1 times 10 raised to the power minus 1, which is equal to 10 raised to the power minus 2. So, the first thing is, once you know this part, that 100 is 10 raised to the power 2, you can easily, know the powers of 10. You have already conquered this standard index form. The next part is to look for the other part of the number, which is less than 10. Because most of the time, you won't have numbers like 100, 1 million straight. You are going to have something like 3,900 or 0.0342. These are the kind of numbers we come across. You can come across something like 11, 232. You can come across all these sort of numbers. But the first thing you should look at is, how do I bring these standard powers of 10 from these numbers? Bring out the standard powers of 10 from these numbers. Let's see how you can go about that. This is going to be 3,900, which means that you are going to have the highest power of 1,000 here. 3,900. So you are going to have 3.9 times 1,000. You can see that. Look at this. 0.00. So this is hundreds. Hundreds. You should have learned that one. So this is 0.03. This is 300s. Hundreds. So you are going to have 3.42 times 0.01. You can see. This is after this. So this is going to be 1.1 times 10. And this is going to be, you can see, it's 232. So we are going to have 2.32 times 100. Once you can express any number and break it down like this, you have already conquered standard form. Now let's look at this one to make it the standard or scientific form. This is going to be 3.9 times 10 raised to the power 10 raised to the power 3. You see? 10 raised to the power 3. So the only thing that you worry about in this standard form is the powers of 10. You don't worry about the powers of this place. Just like we did the normal common indices. In this place, you have said it's standard because it's in power of 10. Now look at this one. It's going to be 3.42 times 10 raised to the power minus 2. You can see. Here, this is just 1.1 times 10. You can write times 10 raised to the power 1, but it's not necessary. 10 is equal to 10 raised to the power 1. So here you have this one to be 2.32 times 10 raised to the power 2. So you can see, it is very easy. This standard index form is very, very useful. It has a wide application in all the STEM. Because there are some numbers which are very large, and to write them, you just need to shorten it like this. Think about Avogadro's constant. That number is so large, like 6 point something times 10 to the power 23. Imagine writing zeros in 23 times anytime you are multiplying. But instead of writing like that, you can just write 6.2 times 10 to the power 23. Another aspect is in the use of common logarithm. This common logarithm is logarithm in the base of 10. And once you can get that one, you can do anything in mathematics because you have the four-figure table and whatever. And that part is in, you get it immediately after this. So once you can do this, you can do the multiplication, you can do the division easily with this. And I think that's the major thing for those who are preparing for their matriculation exams. So it's very simple and straightforward. So the other aspect that you need to learn from this, you should on this the next lecture. So please, if you have not subscribed, kindly subscribe, share, like, and I'd like you to include in the comments any topic you would like us to teach on this platform. I've also been saying this also, that we have classes, you can register, just to hasten your understanding and to also help us in improving or learning more things instead. Thank you. So we go on to some exercises to conclude this. Now to conclude this short lecture, let's quickly do some exercise. For first one, it says write the following numbers in standard form. We have 369, 1. That is 369, which means that the greatest power of 10 is 100. So we can write like this: 3.69 times 100. So it's going to give us 3.69 times 10 raised to the power 2. Well, I need to tell you this. The number of zeros here is the power of 10. So it makes it so easy. So if you have something like this, we always separate. So this one, count the zeros: 1, 2, 3, 1, 2, 3, 1, 2, 3. So that is 9. So this one is automatically 10 raised to the power 9. So it makes the writing of numbers in standard form so easy. Just count the number of zeros, you get your answer. Now let's do the second one first. 705 413. 705 413. So what does that give us? It gives us 705,413. So which means that the greatest power of 10 is 100,000. So it's going to be 7.05 413 times 100,000. You can see if you count it 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. So it's going to give us 7.05413. Please, I counted 6 numbers. But now, how many zeros are we having? We are going to have 1, 2, 3, 4, 5. So, times 10 raised to the power 5. You can see. Times 10 raised to the power 5. Now, let's look at the third one. That is 608.98. 608.98. So, you can see this is 608. That's the significant part. 608. So, we have 6.0898 times 100 times 100. So it's going to be 6.0898 times 10 raised to the power 2. So this is where the focus is. But this one too, you should not neglect it to get it right. What you have here is what you should transpose to this place, but in the correct way. First of all, get the power of 10 by writing separately like this, and then just copy out these ones in the form they are. Maybe it's as decimal or not. Now let's look at the fourth one. We have 0.12345 7684. So by the time you check it, you are going to see 1, 2, 3, 1, 2, 3. So after this decimal point, we are counting 6 figures before we get to the first significant figure here. Or you count straight from there: 1, 2, 3, 4, 5, 6. 6 zeros. So you are going to have 7.684 times 0 point. Let's count. 1, 2, 3, 4, 5. That is it. So we are going to have 7.684 times 10 to the power minus. For this one you have minus 1, 2, 3, 4, 5, 6, minus 6. That's how it is. Now let's look at the next one. It says write the following ordinary numbers. In ordinary numbers, the first one is 3.218 times 10 raised to the power minus 6. So we still come back to get this first. So we are going to have 3.218 times 0.123456. So you can see it's going to be 0.0000000. You see, from this point, here we have 1. That's where we start writing this number. 3218. So you can see it's very simple and straightforward. Know how to convert to the front to standard form, and from there you'll be able to convert back to the ordinary number. Let's go to the next one. You have 2.18 times 10 raised to the power 2. So it's going to be 2.18 times 100. So what does that give us? 218. Very straightforward. 218 is an object. Now the last one. We have 1.41 times 10 to the power minus 5. 1.41 times 10 raised to the power minus 5. So what does this give us? We express this one in longer. That is 1.412 times 0. Excuse me. 0, 1. You can see. So at the end of the day, what are you going to have? I have to write this 0 down. 1, 2, 3, 4, 5. So from here I start writing. From this point of 1, I start writing this out. 1, 4, 1, 2. Yeah, I believe you enjoyed this short class. Thank you very much. Assist us in letting this thing to be known to other people. Tell them about it. Share and then comment. Please, I've also told you any topic you like us to bring to the class, you can include in the comments. And if you want to register or make certain inquiry, the channel to do that is in the description. Thank you very much.